three-dimensional force system. The question here is asking us to determine F5 so that this particle remains in equilibrium. We know that for the particle to remain in equilibrium, we have to apply the equilibrium equations. Sum of all of these forces should equal to 0. Therefore, we have to represent each one of those forces in a Cartesian form. Before we start summing all of these forces, we have to start with our sign convention. So your sign convention, in this case we take this side for positive x-axis, this one here for positive y-axis, and upwards will be positive for the z-axis, and if we have a moment or we're dealing with moment, will be anti-clockwise is positive. Now this is for our sign convention. We're starting, of course, drawing a free body diagram. The free body diagram, we can represent all of them together, or we can represent each force separately. But in this case, I'm going to solve the question as if this is my free body diagram for F1. So the Cartesian form for F1 in this case, so F1 equal, in this case it's a 300. I don't have any coordinates. I've got the similar triangle in this case here, which is 0i plus 4 over 5j plus 3 over 5k. That's F1 in a Cartesian form. F2 equal 600 negative I because F2 it's straight on the negative x-axis, so it's a negative I plus 0j plus 0k, and it doesn't have any components on the y or the z axis. For F3 equal, F3 in this case again it's a downwards straight 900 here, 0 component for I, 0 components for j, negative k. So these are F1, F2 and F3 for in a Cartesian form. For F4 we've got a coordinates for F4, therefore we have to pay attention to this. We have to get the position vector first, then we find the magnitude for F4 in order to represent F4 itself in a Cartesian form. So in this case we have 3 meters of positive x-axis, 4 meters on the negative x-axis, 6 meters on the positive z-axis. Now we say R, the position vector for F4 equal to 3i minus 4j plus 6k. The magnitude for F4 in this case equal to the square root of 3 square, the sum of these positions there, plus negative 4 square plus 6 square. All of that should equal to 7.8. So once we found the position and the magnitude, now we can find the unit vector for F4. So F4 in this case equal to is being given 200 Newton. On the x-axis it's 3i minus 4j plus 6k plus 6k. All of this should be divided by 7.8. So coming in here to expand this and divide it, this will be 600i divided by 7.8 minus 800j divided by 7.8 plus 200k divided by 7.8, and in this case here equal to, when you divide these together, this is 76.9i and minus 102.6j plus 153.8 K in Newton. Now we found this. Now we can apply our equilibrium equations. So sum of the forces on the x-axis should equal to 0. From here we know that F1 on the x-axis plus F2 on the x-axis plus F3 on the x-axis plus F4 on the x-axis plus F5 on the x-axis should equal to 0. So in this case, F1 on the x-axis, it's a 0 I. F2, it's a negative 600 I. It's a negative 600. This is F2. This is this one here. It's F2 straight in there, and we already just expanding for F2 in this case. So for F3 in this case, it's a 0 I. F4, it's 76.9 I, 76.9 I, plus F5 on the x-axis should equal to 0. So F5, for F5, solving for F5 on the x-axis equal to 600 I, and minus 6.9 I. In this case equal to, once you plug this in your calculator, 523 I. So sum of the forces, we repeat the same things. Sum of the forces on the y-axis should equal to 0. And from here we know that F1 on the y-axis plus F2 on the y-axis plus F3 on the y-axis plus F4 on the y-axis plus F5 on the y-axis should equal to 0. Just sub all of these values in there. So for F1 on the y-axis we got it 240J. For F2 it's 0J plus 0 also for 0J for F3, minus 102.6J plus F5 on the y-axis. All of that should equal to 0. So for F5 on the y-axis equal to, and in this case here we know that this is minus 240J when you get this to the other side, plus 102.6J equal to negative 137.4J. Sum of the forces on the z-axis should equal to 0, and again F1 on the z-axis plus F2 on the z-axis plus F3 on the z-axis plus F4 on the z-axis plus F5 on the z-axis. All of it should equal to 0. Just plug in these values in there. That one here it's 180 okay, plus 0 okay. For F3 here it's negative 900 okay, plus 153.8 okay, plus F5 on the z-axis. All of that should equal to 0. So solving for F5 on the z-axis equal to be negative 180 okay, negative that will be plus 900 okay, negative 153.8 okay. All of this will equal to 566 okay. Now we found F5 on the x, y and z axis. Therefore here you will represent F5 will equal here in this case 523i minus 137 j plus 566k. This is F5, and that's what the question asked us to find.